next video, I want to start by talking about something you should be a little bit careful of when applying the strategy of the last video to compute definite integrals, where we first find an indefinite integral. So let me just say you have to be careful about functions that are not continuous. So let me give an example. Let's say that we're looking at little f of x equals 1 over x squared. And we're asked, what is the integral from -1 to 1 of 1 over x squared dx? Well, what is an indefinite integral of 1 over x squared dx? What's a function whose derivative is x to the -2? Minus x to the -1 plus c is such a function. Or maybe a little nicer to write it as -1 over x plus c. This is a function whose derivative, where it's defined, is equal to 1 over x squared, just keeping in mind that 1 over x squared is not defined at x equals 0. So what we said in the last video was you find the most general antiderivative, you pick a simple one, and you evaluate using FTC2. So we have -1 over x, evaluated at 1, evaluated at -1, and we get -1 over 1 minus -1 over -1, which, okay, you have to keep this all straight in your mind. This is 1 minus 1. This is equal to -2. Okay, let's think about this for a second. What does the function 1 over x squared look like? Well, it kind of looks like this. It's not defined at x equals 0. There are these vertical asymptotes that the graph goes off to infinity. But this indefinite integral is asking for the signed area between -1 and 1 under the graph of this function. And we're getting a negative number. But this function is never negative. Right? This function is greater than or equal to 0. So it just doesn't make sense that this area would be -2. So the question is, what went wrong? I mean, it's true that -1 over x is a function whose derivative is 1 over x squared wherever it's defined. But what went wrong is we can't apply FTC2 because the function 1 over x squared is not continuous on the interval from -1 to 1 that's given here. So what is the definite integral from -1 to 0 of 1 over x squared dx? For now, we just don't know. So later on in chapter 7, section 8, I believe, we'll talk about improper integrals, which give us a way to deal with integrals like this, where the function you're integrating is not continuous over the whole range. But for now, I just want to say you have to be careful about applying this strategy automatically, where you try to compute any definite integral by finding an indefinite integral and then evaluating at the endpoints. So this is just something to be aware of that'll come up a little bit. When your function is not continuous, you have to do something else.